A uniform coil of self-inductance 1.8 into 10 power minus 4 Henry and resistance, please make a correction, this is 6 ohms, is broken up into two identical coils. These two coils are then connected in parallel across a 12-volt battery. The circuit time constant and steady state current through the battery respectively are. Okay. So initially we have an inductor coil of inductance R and resistance R. Now it is broken down into two pieces. So what happens to the inductance of each? Inductance of each is L by 2, whereas resistance also becomes half because the length became half. And why did inductance became half? Self-inductance is inversely proportional to the length of the coil or length of the inductor. That is the reason. Now, how are they connected? They are connected in parallel like this to a 12-volt battery. L by 2 and R by 2. L by 2 and R by 2. Now first, let's try to calculate what is the steady state current. In a steady state, the inductor has no role to play and it is only the resistor. Now, these two, R by 2 and R by 2, they are in parallel. So the net resistance becomes R by 4, right? So the R equivalent is R by 4, which is 6 ohms by 4, which is 3 by 2 ohms. So the current or the steady state current is V by R equivalent is 12 by 3 by 2, which is nothing but 8 amperes. From this, I can rule out option B and option D. We have to calculate what is the time constant of the circuit, right? What is the equivalent inductance? These two inductors are in parallel, so equivalent inductance is L by 2 into L by 2 by L by 2 plus L by 2, which is L by 4. R equivalent is R by 4. So tau is L by R, which is nothing but L by 4 by R by 4, which is 1.8 into 10 power minus 4 by R is 6, which is 0.3 into 10 power minus 4 seconds or 30 microseconds. That would be option C.